Today, we are moving from DNS theory into real practical configuration like network engineers. Welcome to the Explainer. Now, if you're a networking student, maybe a beginner, or grinding for that CCNA, you already know the theory, right? The domain name system, or DNS, is basically the phone book of the internet. It's that absolutely critical protocol that translates human-readable domain names, like Google.com, into machine-readable IP addresses. But hey, knowing what it does and knowing how to actually configure it on a Cisco router, those are two entirely different beasts. So today, we're focusing purely on practical Cisco CLI commands. We're going to roll up our sleeves and build this from the ground up using the exact commands you're going to need out there in the real world.
Okay, let's dive into this. Here's our roadmap for today. First, router interface setup. Then, core DNS configuration, local hosts and DHCP, verifying the network, and finally, troubleshooting DNS issues.
All right, starting right off with Section 1, Router Interface Setup.
So here are the core Cisco CLI commands we need to bring our interface to life. Step 1, we got to get into the driver's seat. You'll type Enable to enter Privileged XE mode, and then Configure Terminal to get into Global Configuration mode. Simple enough, right? Then Step 2 is where we tell the router exactly which port we're working on. In this case, Interface Gigabit Ethernet 0/0. For Step 3, we give the router its local identity with the command IP address 192.168.1.1, followed by its subnet mask 255.255.255.0. And finally, Step 4. This is the command every network engineer literally types in their sleep, no shutdown. That command turns the port on. Because let's be real, without these 4 steps, your router is basically just a very expensive paperweight.
Moving right along to Section 2, Core DNS Configuration.
Now, this brilliantly illustrates a really important operational concept. On one hand, we've got IP domain lookup, which lets the router itself resolve domain names. It's actually often on by default. But what if we run no IP domain lookup? Why on earth would an admin want to disable DNS lookups? Well, if you've ever spent any time in the Cisco CLI, you know exactly what happens if you accidentally mistype a command. Say you type enbal instead of enable. The router might think you're trying to connect to a server named enbal, and it'll just sit there completely frozen, trying to broadcast a DNS query for your typo, totally delaying your work. So disabling this lookup is a classic practical engineer trick to avoid those super frustrating CLI hangs.
But assuming we do want our router to resolve names, we have to tell it who to ask, right? We use the command IP name server, followed by the IP address of our DNS server. Right here, we've set 8.8.8, which is Google's public DNS, as our primary. But notice the best practice right below it. We run that same command again with 1.1.1.1 Cloudflare's DNS to set up a backup. That way, if Google's DNS goes down, our network doesn't skip a single beat. Then, that last command, IP domain name company.local, assigns our local domain name, setting the context for the whole internal network.
Next up, Section 3, Local Hosts and DHCP.
Sometimes you don't really need to ask an external server for an IP address. Sometimes you just want your local router to know exactly where a local device is. We can actually manually map host names to IP addresses directly in the router's config. By typing IP host server 1, 192.168.1.10, we're making a permanent local record. And we'll do the exact same thing for our network printer. Why is this so useful? Because as a network engineer, you definitely don't want to memorize dozens of random IP addresses. If the printer goes down, you want to be able to just type ping printer1 into the CLI and let the router instantly know you mean 192.168.1.20. It's all about making your administration practical and, honestly, a lot more efficient.
Now let's move to and see how this builds into a fully automated environment, because we definitely don't want to walk around to 50 different laptops and manually type in DNS settings, right? Instead, we use DHCP, the Dynamic Host Configuration Protocol. Here, we're setting up a DHCP LAN pool. We name the pool, we define the network subnet, and we set the default router. But look at that last bullet point right there, DNS server 8.8.8.8. With just that single command nested inside our DHCP pool, we can automatically push our preferred Google DNS server setting out to every single client device the second it joins the network. How cool is that?
Okay, so we've configured our interfaces, we've set primary and backup DNS servers, mapped local hosts, pushed settings out via DHCP, but here is the ultimate question for any networking pro. How do we know it actually works?
That brings us to Section 4,
verifying the network.
Because configuring the system is only half the job. The other half is proving it, and here is your primary verification toolkit. First up, show running config. This is your absolute baseline. It lets you read the active configuration file to make sure you didn't miss any steps or, make a typo. Next, show hosts is incredibly useful. It displays your manually configured host names, DNS info, and crucially, any temporarily cached entries the router has actually learned. Now, to test if DNS is actively working right now, we simply type ping google.com. If we get a response, boom, we know our router successfully asked 8.8.8.8 to translate the name into an IP. And finally, if we want to verify the exact hop-by-hop path the packets are taking to get there, we just use traceroute google.com.
And lastly, Section 5, troubleshooting DNS issues.
Now, what's really interesting about this slide is how troubleshooting tools change completely depending on the operating system you're actually working from. If a user on a Windows machine complains they can't reach a website, their computer might just be holding on to an outdated cached IP address. The essential command there is ipconfig/flushdns. That wipes the cache clean and forces a brand new lookup. On the flip side, if you're troubleshooting from a Linux environment, you have access to some incredibly powerful querying tools. You can use nslookup google.com to perform a basic targeted DNS query, or you can bust out dig google.com, which gives you a massive amount of detailed technical info about the DNS record itself.
So, let's break down the logic of troubleshooting these common DNS problems. Let's say your DNS server is completely unreachable. Well, your very first step shouldn't be to mess around with your domain names. Your first step is basic connectivity. Check it with a simple ping 8.8.8.8. If that ping fails, you've got a routing or interface problem, my friend, not a DNS problem. On the other hand, if the ping succeeds but names still aren't resolving, you likely have the wrong configuration. Your immediate solution there is to check the file with show running config to ensure you didn't mistype the IP of the name server or just forget a command somewhere. It's all about isolating the problem layer by layer.
And I want to leave you with this thought. Practical skills are what transform networking knowledge into real-world ability. Thank you for watching. If this explainer helped you understand DNS configuration commands, please like this explainer, subscribe to the channel, and turn on notifications for more practical networking lessons. Keep practicing those CLI commands, and I'll see you in the next one.